Hello everyone, welcome back to my channel. Today we're going to be dealing with this algorithm here, and we're going to be using this algorithm to answer this trace table question here. Okay, um so this very pseudocode is question number 6. Okay, so this question is from May-June 2025, the paper 2-3. Okay, that deals with algorithms, programming, and logic. Okay, so we're going to solve this truth table problem using this very algorithm. Okay, so let me just quickly run through this so that you can easily have an understanding of what is required. This is a declaration for an array. Name is store, and it has 100 elements of characters. Okay, so here we have a string declaration, name is word. Here we have index, which is integer. We have letter, which is also a character. Okay, so now the major task will begin from here, which is line 5, where we're going to have the user input word. Okay, and if you check from here, we're told to use this word. Okay, so this is the input that we're going to get, word. All right, so our job is to put this word here, computer. Good. So since this word is here, now the next thing we need to do is to move on to this line. Now if you watch, this line says for index, so index will be from 1 to the length of word. Okay, so and then for each of the loops we will take a substring of word. So this substring word index, so during the first loop the index is 1, so it's 1 1, so it means from element 1, element in position 1. So in this case, since this array begins from 1, the element is C, so take 1 character. Okay, so that means we're taking C only, so this substring, this letter will be equal to C. Okay, so meanwhile here you put the value of your index, which is 1, and then letter becomes C. Okay, so you need to take note of that. Now after that, we're into this very case here, so we need to check case of letter. So if it is equal to any of this, then this should happen. If it is not, then we need to move on to the next. Okay, so because none of these letters is equal to C, okay, so we'll escape this very case here, and then we're moving to store index later. So here is the store, okay, that we have, which is the array. This is element 1 all the way to 8. All right, so that means for index 1, remember that index here is 1, so the value should be here, and then the value would be C, because letter is C here. Okay, and C is equal to the index, the element in index 1. Get it? All right, let's proceed. Since we've done this, now this loop needs to start again. We can't come here yet. Next index, so index becomes 2 here. Okay, so what you're going to have here is this word computer, and then you have 2 1. So take the index in position, the element in position 2. So in our case, this is position 1, this is 2, so so this letter will be equal to 0. So this will not happen, this will not happen, this won't happen, but this is going to happen. Okay, 0. So again, so we're done with this very part, so we're starting all over again. Now remember that your index is now 2. I'm sorry, I'm supposed to have done that. And then your letter is what? O, not 0, O. Okay, so now when you get here, this letter will now become empty. Okay, it will now become empty. Now there are two ways that we can do this. Now some persons may say, okay, let us equally capture that here and leave this space empty, and some persons may just continue. Now which ever approach you take will still work. I will explain that when we're comparing our answer with the mark scheme. Yeah, okay, so I'm going to take the approach where I will leave here empty because this value has changed. Yeah, so I will now begin to enter from this end. Okay, so that will happen, and then here store index later. So the number 2 here, which is this one, will take the value of later, and the value of later here is empty. So this guy is basically empty. Yeah, it's basically empty. All right, so what next do we need to do? We're done with this one. Okay, so some persons may choose to leave this line empty in order to accommodate what happened here and continue writing, and some persons may just continue writing here. Like I explained earlier, whichever approach you take, you are right, and I will explain when we are comparing with the mark scheme. Okay, so the next loop, it's in that is the index will become 3. Okay, so that will be 1 2 3 letter M. So our index here, so since I decided to leave this line, so let me write 3 here, right? So if the index is 3, that means that later should be M. Yeah, M, and then there is no M here, so none of this will happen. And then when we get here, since the index is 3, at index 3 this will become M. Okay, uppercase M. Please take note of that, uppercase M. All right, so you see, so we will start again when index becomes 4. When index becomes 4, we're dealing with P. Yeah, later P. So none of this will happen, but this is going to happen. So later is because it's P here. So at index 4, this will become P. Get it? Okay. Now the next loop, index will become 5, and then what is in position 5? That's U. Later will become U. Okay, later will become U. Now looking at the case here, this is going to happen. So like I explained, I'm going to leave this end empty in order to accommodate what has happened. Okay, so here equally, that will be later 5, that's here, that's index 5, will equally be left empty. Okay, so the next loop, index will be 6. Okay, so now that index is 6, what is the element in index 6? Yeah, you guessed right, that's a T. Okay, T is the element in index 6. Again, none of this is going to happen because there's no T here, so we just go back to index 6 and this becomes T. Yeah, and then the next loop will have 7 here, that is index is now 7. Okay, and later will become E. Later will become E. Okay, so because later is E, what will happen? This is going to take place. This later will be equal to empty. Okay, so again I will choose to leave here empty, and then we'll jump down to store. Store at position 7 will become empty. So I'm just using this to mark out the places that we left empty. Okay, and then after that the index becomes 8. Yeah, the reason this index is getting up to 8 is simply because there are 8 characters here. 1 2 3 4 5 6 7 8. So in case I didn't explain that earlier. All right, so index 8 is R, right? So later will become R, and then none of this is going to happen. Then we can come to this end here, and then here becomes R, right? Okay, so what next do we need to do? So after then, that means that this loop would have completed. So we now need to move to the next line, which is another loop. So what does this loop do? He said so it's going to run from 1 to the length of word, that means it's going to run 8 times, yeah, from 1 to 8 there. So if store index, so the first time store 1, so we're starting from here now, so the index here becomes 1, yeah, index here is 1. So when index is 1, store 1 from here is C, yeah, store 1 is C, and that is what will be outputted. So this one, and then we just jump all the way to C here, and then we print C. You understand? Yeah. So, and the reason we're printing C is because this place is not empty. This means if this element is not empty, it's not a null value, print it. So that's why we're outputting it. You understand? So we move on to the next iteration. So the value of index becomes 2. So when the value of index is 2, you know, all of this doesn't happen, so all we are looking at is the output. Yeah, good. So index output, index output. Okay, so here you say if store, so is the element 2 here empty? It is empty. Since it is empty, it is not going to show up. Yeah, so we leave there blank the way it is, and then the next iteration, okay, here becomes 3, which is the index. So is this position empty? No, it is not. Okay, so since it is not empty, so you go back to here, index 3. This index 3 is not empty, so this is true, and the printout is going to happen. So what are we printing here? We're printing M. Yeah, so again we move to the fourth iteration, okay, which is where the index becomes 4. So store index 4. So let's go store index 4. Okay, it's not empty, so the output is going to take place. Okay, so output will be P. Okay, now the next iteration, your index will be 5. Again, we'll check store index 5. Where is store index 5? Store index 5 is empty, so this is not going to happen, so it will skip. Yeah, and then we'll move to the sixth iteration. So index store 6 here. So let's go back to store 6 here. Store 6 is not empty, so this is going to happen. The output is going to happen. It will output T. Yeah, and then, oh, sorry, I shouldn't have written this here. Sorry about that. It should be written here. Okay, so 6, yeah, is T, so it should be written here, and this place should still be left empty. All right, so after that we'll go to the 7th iteration, and then the 7th iteration, index is 7, and then we need to check 7 here. 7 here is empty. It's because it is empty, so this is not going to happen, so we're skipping this part. Yeah, we're skipping this part, and then to the next iteration, which is 8. That is, your index is 8, and then we check store 8. Store 8 is not empty, so this is going to happen, so we will output R here. This is not supposed to be here. Okay, it is supposed to be under 8, so we need to take note of it, that sometimes when we have problems like this, you can see that I practically make the same mistake twice, 1 and 2. So we need to be extra careful to make sure that we are aligning it with the place that it should be. Okay, all right, please, it is very, very important. From the math scheme, you would see that when we mark columnly. Now if you look at the math scheme here, you would realize that the mark points are based on columns. You see, correct word and letter columns. So 1 mark for correct word and letter. So we're looking at the columns. Now, irrespective of whether you have space between the 2 and the 3, irrespective of the space, okay, what we're looking at is after 1, what is the next value? Is it 2? After 2, what is the next value? Okay, the next value, not whether it's empty or not. So as long as there is 2, you have 2 and then 3, whether there's a space here or not, the student will still have the required mark. So which is the reason I told you guys that it doesn't really matter if we choose to take an account of this part of the program or not. Okay, the marks will still be given as long as you wrote the next value that should be entered. Okay, so again the same thing follows up with the later part, the same thing. So here if you check, you'll see that they are marking the column only. Okay, they say correct store 1 2 3, you see 1 3 4 6 8, 1 3 4 6 8. The marks are not given horizontally, they are given by the columns. Okay, they are given by the columns, right? So with that, our answer is as correct as the mark scheme as well. Okay, so that's what we have there. So I hope this is clearly understood. Okay, I hope this is clearly understood, and it makes a lot of sense. Okay, so if you find this video interesting, if you've learned something from this video, please do well to subscribe, do well to like, do well to share. Okay, that way this video gets to as many persons as possible. All right, so let us know if there's any particular question you want us to handle in any part, whether it's paper 1 or 2. Okay, as we'll try to check our comment and try to attend to the request that you have. Thank you very much. I'll see you guys again in the next video. Bye for now.